Welcome to funcprogsweden number 5. First, we would like to thank, as always, all our recurring viewers, and all new viewers, you're also warm welcome. Head over to the agenda for today. First, we'll have a short introduction by me, Magnus, and then we have functional programming in Python, ? Is it possible? By David Vujic. And then the second presentation is Virtual Machines for Functional Languages by Erik Happy Stenman. And then in the end I'll do a schedule and a summary. First, I would like to thank our video sponsor, OtherBeat. OtherBeat is a small but growing consultancy company with office in Stockholm and in Ho Chi Minh. If you want to know more about OtherBeat, please check them out in social media or on otherbeat.com. If you want to support the funcprogsweden community, join the meetup community. Follow us in the YouTube channel, on the YouTube channel funcprogsweden. And, of course, check out the merchandise store on funcprogsweden.myspreadshop.net, where you can buy nice t-shirts like this. If you have questions during the presentation, please use the chat to ask them, and I will read them up for the presenters. And please don't hesitate to ask questions. With that, let's get started. And our first presentation, Functional Programming in Python by David. Welcome, David, to us.
Thank you.
Thank you. This is the second time around you're here.
Yeah.
Last time you had like Clojure script with React or Hiccup.
Yeah, that's
Yes.
right. Clojure script and like
Yes.
front-end programming.
Exactly. And now you're back with Python.
This time it's Python.
Yeah? It's more back-end?
More back-end focused this time, yes.
Interesting.
Yeah.
Yeah. I will hand over the cable to you
Great.
so you can get your presentation started. Voila, David.
Thank you.
Let's see if it comes up. It's always a magic thing, if it works or not.
Moment of truth.
Yeah, exactly.
What happens if I wake my computer up?
Or no.
Nothing happens.
Yay.
Oops.
It comes up. And now you have the pixel raining.
Yeah. I made that in Python. No.
Ooh. This is front-end programming with the Hiccup.
Will something happen if I do something else? Should I change the resolution or something?
We'll see. We got it working just before we started.
Yeah.
As always, the demo monster is here. Welcome, David. The stage is yours.
Thank you. Okay, welcome to this talk about functional programming in Python, ? My name is David. I'm a developer. I live and work here in Stockholm, Sweden. And currently I work as a full-time Python developer. And I previously have coded in Clojure, in JavaScript, and Node.js, and C# also. And when I came back to Python not too long ago, from a functional programming language, I was thinking if it would be like possible to use some of the good stuff that I've learned from Clojure and Clojure script. So this talk is going to be a little bit about that. And I'm thinking about this. The talk could be like in three parts. The first part will be, I will talk about functions, you know, the basics of programming, or basics of functional programming is writing functions. And also try to talk about a functional approach to how to data, how we can separate functions and data using functional programming in Python. And one section will be about the developer experience, about tools and workflows that will make our daily work as developers joyful. Yes. And I'm also, there's something called the Zen of Python, or writing Pythonic code. If you haven't heard about it before, it's sort of it's a set of rules or guidelines on how to write Python. I think I have another, yeah, this one. So if you would like open a Python shell or a terminal and start a Python shell and write import this, you would get this list called the Zen of Python. So it's sort of a Easter egg implemented in the Python shell. So here you can find like ideas on what good Pythonic code is about. And when I came back to writing full-time Python, I went back to reading this list and to see with my newly learned functional mindset if this the functional idea is applicable to these ideas, the Zen of Python. And when just quickly browsing, I thought, hey, this looks like functional to me. So I started to code and started to learn more, and I had this list in the back of my head. And after a while, I realized one thing. There's especially on line 16, where there should be one, and preferably only one obvious way to do it. But from my experience, solving a problem in Python can be done in several ways, in at least 3 ways, probably more. I'm going to show you what I mean by this. I'm going to go back to my editor, code editor. And I have a file here. And here's some code, the two functions, basically doing the same thing. So I'm starting by declaring a list of words, and what the functions are trying to do is they accept that list and trying to find a word in that list. And if it's found, it's going to return it. And the first one, I think that's a very common way of writing Python code. You take a list and you iterate through it using a for loop, and for each iteration you look at the item and compare it if it meets your requirements. If that's true, then you return the data that you have found. I think this is a very common way of writing Python. And the second function does the same thing, but I tried to write it in a more functional way or something like that. So instead of doing that for loop, I used the built-in filter function. And the filter function accepts a predicate, which do actually that matching of the requirements you have for that filter. And in Python, the filter function will return a lazy object, iterator, and to just get the first item, you can use the built-in next function. So that's 2 different ways of writing the same solution in Python. I'm going to try to write it in another way. Find word, and probably I want to try to write it in a more Pythonic way. Okay, good. Maybe that's better. So it's going to accept the same kind of input, like this. So instead of using that filter, I'm going to use something called comprehensions. Something like that. And a comprehension is a special feature in Python. And what I chose a generator comprehension, and that one also returns that iterator object that you can run the next function on. So if we quickly browse these three functions, to me it looks like the third one is sort of a combination of the first two ones. It looks like some kind of a for loop in there, but it's just a one-liner and returning that iterator. So probably, I think the third one is probably the most Pythonic of these three functions. Then I'm not sure if the comprehension is strictly functional, but I think it's a good balance between Python and functional in general to use comprehensions. And there's I used generator comprehensions, and we also have list comprehensions and dictionary comprehensions. Okay, so that was one example. Okay, so I'm going to move on to a different example, like this. So here I have a function that accepts a dictionary, some data, and add stuff to that data, and then return it. And I think this is quite a common way to writing functions where you want to like add things to an object. What I'm doing then, I'm also printing it out. So I'm going to try to actually run this function. Functions and add things. So what it does, it prints out that dictionary, and starting with the name and added hello world. So what I'm going to do next is I'm also going to print the original data source, like that, and run that function again. So first I print out the result from the function call, and then the original data. And as you can see, the both have been changed. And that shouldn't be any surprise, because I actually do things to an existing object like this. So if you would use a functional term, you could say that I mutate the data. And I think it's very common in Python because it's so easy to do it. Data in Python is mutable. It's not immutable. So you can change objects just the way you want. But mutability is mutating data. It's also something that could introduce potential risks or unwanted side effects. So we want to avoid mutations, and that can easily be done in Python too. So I'm going to, instead of adding data to that object, I'm going to use some fairly new syntax in Python. And just going to delete that row. So if we run this function again, you can see the first row there, that's the result of that function call, and the second row is the original data source. So what I'm doing here, instead of mutating the existing data source, I'm merging two dictionaries. I'm taking my original object and the new data and merge them together. And since I think Python 3.9, the pipe operator is how you can merge two dictionaries. Okay. So I'm going to move on to a little bit more of a real world example. Like this. So on my spare time, I'm working, just probably as many of you do, working on an open source project. And that thing that I've been working on is a program that works with files on a file system. And what I wanted to do, I wanted to be able to to start from a folder in my file system and look for a file, and I wanted to traverse the dictionaries or directories upwards. So looking for a file in this directory, then traverse up to next one and next one and next one. So I Googled and I found this nice and elegant function in Stack Overflow. So I just was about to start using it because I thought it was nice and simple and just a few lines of code. But then I realized what I really wanted was to be able to I wanted to be able to determine which folder which directory to start from. This function assumes that the directory that you are in currently will be where you want to start. I want to pass in that to this function instead. Then I looked a little bit closer to what's happening in this function. So it declares the current directory and also the root, and have a sort of a guard not to traverse beyond the root folder. And then if it doesn't find the file, it's going to reset the current directory to its parent and loop until that statement above is true. So I'm thinking, what will happen if I will pass in a directory that will internally be mutated? So I wanted to avoid that, just as the example before. So I ended up in refactoring this code. Nope. Into something like this. So this function below here accepts a working directory. I still have these guards to check if I'm on the root or not, but if the file isn't found, I'm calling the function itself. So I'm using something called, a very common thing in functional programming called recursion. So instead of the current working directory, I'm sending the parent of that one. If it's not found, it's going to send that parent. So traversing upwards until I find that file, and if not found, I will return none, just like the previous function. And the result, it got a lot fewer rows, and I don't mutate any data. So this is also an example on how you can avoid mutation by doing calling the function itself, recursion. Okay. So moving on to another example. Oops. So, and as opposed to the previous one, this is totally made up. This is a totally made up example. So if you can imagine, after the pandemic, people start going back to the offices again. And but during the pandemic, it might be that your company has grown. There's a lot more people now than like 2 years ago. So we need some sort of system or app to keep track on the office itself. Is there any available desks in the office when I'm going to work there? So I started on prototyping this, and figured out that, well, we have like some sort of object, some sort of office, and the office has a number of desks. And the office is a class, and each desk is also a class. And you can ask each desk if it's free or not. And the office also has a function or a method that you can query if there are any available desks in the office. And this approach is could be seen as like an object-oriented approach to solving a problem. So if I'm going to put my functional glasses on, or having a functional approach to this, what I usually do, what I think it's quite common to do, is to identify the different parts of a problem or a program. Let's say I want to refactor this. So what I'm trying to do is to identify what is the data in this code, and what kind of calculations is done on this data. So if I can identify and separate those two things, so and I actually gave that a try. So I'm going to put this refactoring next to it, like this. So instead of one office and a desk, I saw both of these objects as basically data, and the thing to check if an office is if a desk is free or not is a calculation on it. And what I think is quite common in functional programming, at least in languages like Clojure and equal, is that representing data is a good thing of representing data is to use just basic data types like dictionaries or lists and things like that. So I identified this office as a dictionary, and with one key called desks, and that key contains is a list of other dictionaries, which is a list of desks. And by doing this, I can send this data, just a regular dictionary, where I know like the API of what to do with that dictionary, to a generic function that can do that calculation on it. And as you can see, the code, amount of code is a lot less than this version. And I'm probably being totally unfair to the object-oriented version here. It can be done a lot better. But I want to show you kind of a difference in the mindset of using functional versus object-oriented programming. So in functional, you would identify the different types of the different things in a program, like data, calculations, and if you would do any updates or inserts, that would be an action. So you can separate these three, and you can start writing pure, simple functions based on that thing. Okay. I'm going to turn this off a bit. I'm thinking about going back to this search function. And if you remember, I was going to my terminal and was executing some Python code. You can also start a Python shell if you want to experiment with code, and that's cool. But one thing that I have learned from mainly from Clojure is that you can use the terminal or the REPL in a much better way, which is a thing called REPL Driven Development. And I was trying to investigate if that thing was possible in other languages like Python, and I think it's you can actually do it. So what I'm going to do here is I'm going to fire up a Python shell within my editor. But I'm not going to write any code down here. What I'm going to do is that I'm going to continue working where my code lives, in the editor. So capture the result, and then I can evaluate the code as I type. So I'm evaluating the result of this search upwards thing, and I can continue experimenting like this. Oh, it's found the file name is the one that I actually looked for. I can execute functions, and get the result in the terminal. So by doing this, I think this is a much smoother way to experiment and test your code than navigating back and forth between your editor and a separate shell. So I'm staying here where I have my autocomplete and like all the support. I can navigate back and forth and things like that. So that's kind of REPL driven development in Python using there's some setup you need to do in your editor. I'm using Emacs, but I'm pretty sure that this thing works in PyCharm or VS Code or whatever your favorite editor is. Okay, so that was REPL driven development. So I'm going to show you one last example of what I think is really good, a really good thing that I have learned and want to bring from the functional mindset or functional ideas into Python. And I'm going to demo. I have some example code here. So I have some code here. So I'm working on an app that takes CSV files and parses them. And this function is some sort of a validator. It validates the CSV of that file. So I'm opening it and I'm extracting the headers and I'm looping through each header and try to do some sort of validation and return a Boolean if the CSV seems valid or not. And I think I can run this in the repo like that. Yeah, it seems to be a valid CSV. But I also have a file called empty.csv here somewhere. Let's give that one a try. Boom, my code explodes. And that's because the code here has expectations of the CSV that I hadn't thought about before. So what can be done? So, well, I thought it might be good. Maybe I need to do some, have some handling some errors in this code. So I added some error handling by wrapping parts of the code in TryCatch statements. So if something will go wrong when I open a file, I can handle that and return false. If the headers, if I get a key error because the data is not there, I can handle that one. I think that was actually the case before. And just to be certain, I'm going to add a try catch here, try except when I loop, because what if the headers is empty and I'm trying to iterate a non-object, and then things will start to break too. So I better have a try exception there too. So, and then I grabbed a cup of coffee and came back to the computer and saw this code started to be quite a lot difficult to follow because there's a lot of exit points and things like that. So I tried to actually, well, maybe I need to do some sort of refactoring. Maybe I can extract this into separate functions. So I did that. So here's my entry point. It's nice and clean. It's sort of almost like it's piping data from the input of the output of this. It's input to next function and continuing like that. And I have kind of sort of hidden the error handling in each function like this. Try except, try except, try except. So maybe the entry point got a little bit cleaner, but it's still quite a mess. And you know, this is just example code and just one line, but I guess you can imagine real code running in production that has a couple of rows more than this simplistic example. So so what I've learned from mainly from Clojure, but I think it originates from F#, is a way to write your code using a happy path style. Because what I want to do is I want to ignore all these error handling. I just want my function to do what it's supposed to do. And one way to solve that is to use a pattern called railway-oriented programming. So I've tried to implement this idea in Python. There are libraries already that you can use, but I thought it would be a fun idea to experiment and try to understand the ideas behind railway-oriented programming. So my functions ended up looking something like this instead. So I've still extracted each part into separate functions. The entry point looks basically the same. It's piping data, input, output, input, output. But the functions there, they have I've removed the error handling in the functions and instead decorated it with I've decorated the functions. And railway-oriented programming is a way to, if you have a function, you want to make the function into a two-track function. So if you run code in your function and something goes wrong, you will take the next step will be a different path, because something went wrong and you will bypass the rest of the flow, and then you can have a look in the end what was the result. Did it success or did it fail? And so I implemented that by decorating my functions like this. So if something would go wrong here, the errors will be handled, but not in this function. So if we have a look in how this works, so I'm navigating a bit into that decorator. So what's actually been handling is a try except actually. So I run my function here, and if it fails, I'm going to handle that error and return a different kind of object, a fail object. And that object contains the error information, which function failed, and anything that you like, basically. And in the next step, when that data failed object will be passed to the next function, but the decorator will make sure to check the incoming data. If it is a type of failed object, it's going to skip the flow of that function. So it's just going to return and exit a function. So in the end, what I do here is if it goes wrong somewhere in this flow, this is handled, and the result will tell me in the end if it went well or if it failed, and then I can handle that failure. And this is just I'm just scratching the surface on railway-oriented programming, but this is just a basic example on how you can write code using a happy path style and from a functional pattern into Python. And I think basically that's what I had to say today. So I've gone through, I talked about functions and avoiding mutations, how you can see data using functional mindset, and the developer experience using REPL driven development, and some patterns like railway-oriented programming. Thank you for listening. And all code is in my GitHub, so if you want to look, or please contact me if you have any questions. Thank you.
Thank you very much, David.
Thank you.
I have a request. REPL Driven Development, how did you do it with Python?
Yes.
Did you have some magic code, or can people check it up on your GitHub?
Yes, they can. I have it I should have linked to my other repo. I can do that maybe in the comments, because I have a configuration for my editor describing how you can set up your editor to make this REPL driven thing work nicely.
Good. Thank you very much. Then I have next question. Have the functional type of thinking helped you when you write Python now? Has it made the code better? The Python code better?
I think so.
Yep.
I think it has helped me to isolate problems or problems to solve, and in a more like structured way. I don't nowadays I get a little bit headache when I see a function with too many too many stuff in it. So I want to extract and understand the problem, and for me it's easier to understand if you have like simple functions with input and output. So I think it has helped me.
Yep. Have you seen less bugs or less maintenance issues?
I don't.
Or is it too early?
It's probably too early, and I have less bugs than if I go back to the things I did like a couple of years ago, definitely. But I don't know if the code that I have done now would be has less bug than if I would choose another approach.
Yes. Have you gotten any comments from your teammates?
Yes, I think mostly positive. I've started to introduce this railway thing is still left to do. I'm going to try to introduce the teams to that, because we do a lot of code with many exit points and handling errors in line and things like that. So I think this approach would be fit quite nicely there, but we're not there yet.
Yes, then again, thank you very much. I'm going to see. Oh, no more questions in the chat. Thank you very much again, David.
Yeah, thank you for having me. Thanks.
And